Wonderful. Good afternoon, everyone. Welcome to our Climate Action Beacon webinar, the first one of 2024. And we're going to start with a bang. So let me introduce myself. I'm Professor Susan Harris-Rimmer. I lead the climate justice theme of the Climate Action Beacon. And today I'm here to introduce our illustrious leader, dear leader, we call him. Not really, no. We are very excited to introduce Professor Brendan Mackey. Today he's going to be speaking on how we can promote the wise use of net zero emission commitments. So let me tell you a bit about Brendan. He's the director of the Beacon, as I've explained, which is a large commitment by the university to a different kind of research, a transdisciplinary research over 5 years. There's about 70 academics involved and a wide range of projects. And the idea is to really try to have impact on our communities, on our nation, on the world, in order to motivate and promote evidence-based climate transitions, climate action. Brendan has a PhD in plant ecology from the Australian National University. He has over 300 academic publications. If you're an academic, I'd like you to just spend a little time thumping your head on your desk. 300 publications, 12 last year. So, wow. And they're all in the fields of climate change research and biodiversity, environmental science, and environmental policy. Brendan was a coordinating lead author for the 2022 Intergovernmental Panel on Climate Change, which is the IPCC 6 Assessment Report Working Group 2 on Impacts, Vulnerability and Adaptation. He's a very passionate activist and advocate for environmental issues, and we're very grateful to have his expertise today to speak on the wise use of net zero emission commitments. Over to you, Brendan.
Thanks, Susan. And let me see if I can get rid of that little box. And to begin, first of all, thank you for that introduction, and thanks to everyone who's joining us and making the time to be with us today. Let me begin with acknowledgement of country. I'd like to acknowledge the people who are the traditional owner custodians of the land on which we're all meeting, and pay respect to elders past and present, and to other Aboriginal and Torres Strait Islander and First Nation people with us today. And I'll note that the Gold Coast, where I'm talking to you from, is situated on the land of the Unga peoples. So as Sue said, today I want to talk about how we can promote the wise use of net zero emission commitments. This means we've got to cover a bit of climate science and quite a lot of climate policy. Here's an overview of what I'm going to be covering. I want to talk about the mitigation imperative, both the scientific and social meanings of net zero emissions, what this means in terms of our decarbonisation transition planning. In particular, I want to focus on the challenge of dealing with Scope 3 emissions in that context and provide some recommendations rather regarding guidance for our net zero emission plans and transition planning. And I've got there a screenshot of the cover of the recently released State of the Global Climate Report for 2023 by the World Meteorological Organization. If you're looking for evidence for why we have what I think can now be called a climate crisis, this document is a very sobering update on our current situation. Well, speaking of current situations, this is the most recent report, which is released annually by the Global Carbon Project. That graph is showing you annual fossil fuel CO2 emissions starting around 1990, and the most recent assessment, which is 23, which shows us we're emitting about 37.5 gigatonne of fossil fuel CO2 annually. So when we're talking about net zero emissions, this is the prime target of what we're trying to deal with. And keep in mind that the climate change impact of fossil fuel is based upon the accumulated greenhouse gas emissions in the atmosphere. In addition to fossil fuel emissions, we also have emissions from land use change, or more formally known as land use change and forestry, much of which come from deforestation and forest degradation. And this is also a graph from the Global Carbon Project's 2023 report, which shows annual CO2 net emissions, which I need to explain, from about 1960 to currently. You see that the net emissions are around 4 gigaton, which is about 10%. In terms of accumulated emissions since the Industrial Revolution, it's actually about a third of the additional greenhouse gas emissions in the atmosphere are from land use change and forestry. Annually now it's only about 10% per year because, relatively speaking, we're getting much more fossil fuel emissions. The point I make on the left-hand side is we normally discuss this in terms of annual net removals of atmospheric CO2, but the real mitigation power of ecosystems, and forests in particular, is the retained accumulated ecosystem carbon stock. On the right-hand side, I've got some numbers to try and explain this concept of net emissions, or net emissions, because this is kind of fundamental to thinking about net zero emissions. The figures on the right are averaged over 10 years. So averaged over 10 years, it's a paper by Nancy Harris. The annual net forest removals are about minus 7.6, i.e. the forests of the world removed about 7.5 gigaton of carbon annually. A gigaton is a billion tons of carbon. But actually, the gross removals were twice that, right? 15.6 gigaton of carbon. So when we talk about net emissions, we have to take into account the emissions that are lost back into the atmosphere from deforestation and forest degradation and other land use activities. And that's about half, it's about 8 gigaton. So just kind of rounding it off, ecosystems remove about 16 billion tonnes a year of carbon, but we lose half of it straight back into the atmosphere due to deforestation and degradation. So that's why we talk about net emissions in the land sector. When it comes to fossil fuel emissions, of course, they're only one way, because naturally our fossil fuel reserves of oil, gas and coal were not naturally degassing into the atmosphere. So when we look at the mitigation challenge in terms of achieving net zero emissions, again, this is from the Global Carbon Project's most recent report. This is the remaining carbon budget to limit global warming to 1.5, 1.7 and 2 degrees. The carbon budget is, if you like, the permissible carbon we can emit into the atmosphere before we hit a given level of global warming. Note though, it says those 3 levels of global warming with 50% likelihood. Just as an aside, if I was generating statistics about a risk to the future and survival of life on Earth as we know it, I would want a little bit higher than 50% likelihood. I would probably be going for 99% likelihood. Nonetheless, they're the numbers we have to talk about today. But the point is, to limit global warming to no more than 1.5 degrees, there's only 275 gigaton of actually CO2 left. And I told you on the previous slide, we're emitting about 35 gigaton a year. So there's only 7 years before we hit 1.5 degrees, which we're going to do, right? So the mitigation imperative is we have a very fixed amount of carbon left to release into the atmosphere before we reach 1.5, hit 1.7, or even hit 2 degrees. It's actually 7, 15 and 28 years left. And in terms of the timeline, we have to achieve those net zero emissions over what I would actually argue are precipitous timelines. So these are 3 global CO2 pathways using those remaining carbon budgets between now, which is the black line starting in 2000 up to 2023. And the green is the pathway for net zero emissions to limit warming to 1.5 degrees, the blue for 1.7, and the blue for 2 degrees. So when we talk about net zero emissions, this is what we're talking about. Our success or failure to do that and the rate at which we do it will determine which of those pathways we follow. The good news is the world community has now committed to a pathway or pathways to decarbonisation and a climate transition. This is the text from the decision text from last year's UN framework and the Conference of the Parties for the Paris Agreement. It was COP28. This was decision 28. It's just a coincidence. It was the 28th decision and the 28th COP. It's worth reading at least the first few paragraphs. Recognises the need for deep, rapid and sustained reduction in greenhouse gas emissions in line with 1.5 degree pathways and calls on parties, which are the governments of the world, to contribute to the following global efforts. A is tripling renewable energy capacity by 2030. B is accelerating efforts towards the phase down of unabated coal power. C is accelerating global efforts globally towards net zero emission energy systems. And D, transiting away from fossil fuels in energy systems in a just, orderly and equitable manner, accelerating action in this critical decade. So the governments of the world have now committed to a decarbonisation pathway and a net zero emission pathway this decade. But climate policy and climate action is actually lagging. It's lagging the pledges, and it's actually lagging what we need to be on those pathways that I showed you before. This is from the Climate Action Tracker website, and the blue shows you where current policies which are being implemented will land us in terms of global warming by the end of this century. It's somewhere between 2.2 to 3.4 degrees, with a mean kind of estimate of around 2.7. And on the right-hand side, you can see what's called the optimistic scenario. That's when everything that people have talked about doing is fully implemented, including LTSs, which is the long-term strategies, etc., etc. We're still well over the Paris Agreement target. So given this, there's been a big push and a welcome push for non-state actors to also make net zero emission commitments in support of their national governments and even help accelerate actions ahead of their national governments in meeting Paris Agreement global warming goal. So in addition to the 140 countries, we've now had 9,000 companies and 1,000 educational institutions, amongst others, who have all committed to net zero emissions and are putting in place or developing climate transition plans, including decarbonisation plans. And to help guide that, to make sure it's got some integrity, at COP26 in Glasgow, a transition plan task force was launched in April 2022 to establish what they call the gold standard for these transition plans, to make sure that they have integrity and that there's some consistency across these sectors. So that's all very good news and very much to be welcomed, and universities like Griffith are part of those 1,000 educational institutions. Now I just want to unpack a little bit about how net zero emissions, that term has, if you like, a spread through society. So in addition to the kind of scientific meaning and definition and understanding, which I've taken a bit of time to explain, it also has now assumed various social and political meanings. Well, there's a legal basis for net zero emissions, which is actually well grounded in the science, and that's Article 4.1 of the Paris Agreement. In order to achieve the long-term temperature goal set out in Article 2, parties aim to reach global peaking of greenhouse gas emissions as soon as possible, recognising that peaking will take longer for developing country parties, and to undertake, and these italicised bits are my italicising, to undertake rapid reductions thereafter in accordance with best available science, so as to achieve a balance between anthropogenic emissions by sources and removals by sinks of greenhouse gases in the second half of this century. Achieve a balance between anthropogenic emissions by sources and removal by sinks of greenhouse gases. And it goes on to say on the basis of equity and in the context of sustainable development and efforts to eradicate poverty, which is also saying we have to do this in the context of what we're now referring to as climate justice. So let's drill down a little bit more. We've talked about the anthropogenic emissions by sources. It's burning fossil fuel for energy, coal, gas, and oil. It's also emissions from cement production, which are quite significant, and also emissions from land use change, and forestry, which is largely deforestation and forest degradation. But what do we mean by sinks? What are the sinks? Going backwards. So to understand that, we need to unpack a little bit more what the scientific definition of NZE is. And to do that, I've got to show you something about, or explain a bit about, the global carbon cycle. And what I'm going to show you is a very simplified version of the global carbon cycle. If anyone who knows about the global carbon in detail will know how simplified this is, but it presents the main components for the purpose of this talk. So there we have the atmosphere, we have the ocean. On the right-hand side, there's some depiction of fossil fuel carbon. On the left-hand side is what we're doing to land. I talked about how ecosystems remove carbon from the atmosphere. Some of it's stored in the biomass and soils of ecosystems. We've got land use change happening where we're clearing and degrading forests and putting more of that carbon back into the atmosphere. And we're using fossil fuel and putting CO2 emissions in the atmosphere. But in addition, the point of this diagram is we've got two things going on here simultaneously. We've got these anthropogenic emissions from fossil fuel use and deforestation, degradation, land use change, and we've got the natural cycling of carbon between the atmosphere and ecosystems on land and between the atmosphere and the oceans. This is largely a physical process. CO2 just dissolves into water, becomes an inorganic carbonate. Now, what happens to that? And if you look at the numbers, they're just kind of annualized numbers of gigatons of carbon. You can see they're very similar. The amount of carbon that's naturally removed by ecosystems, most of it's released in a year, and the same with the ocean. Most of what's absorbed is released within a year, degassed again. But a fraction of it isn't. Somewhere between 2 or 4% is retained either with ecosystems or within the ocean, and a fraction of that ends up at the bottom of the ocean. And that's what I've shown there. So you've got surface ocean mixing, 900 gigatons of carbon. Intermediate and deep ocean mixing, 37,000 gigatons of carbon. And in the ocean floor sediments, there's another couple of thousand gigatons of carbon. This is where most of the carbon that's naturally degassed from volcanic activity or from major events on land ends up. So these are the two natural sinks, this uptake and retention by ecosystems and the long-term deposition of carbon in the ocean. Now that's a complex process. The ocean process is very complex. Getting into the water is physical, but there's what's called a biotic pump. There's the weathering of rock, the deposition of dead organic matter and sedimentation processes. And actually rain falling on land weathers rock, which also puts carbon into the ocean as well. But all you've got to take away here is when we talk about the sinks in the global carbon cycle, the main sink is the bottom of the ocean, and a minor but still important sink, or a secondary but still important sink, more of a buffer, if you like, ecosystem. So from a scientific point of view, net zero emission means net zero emissions is achieved when human-caused CO2 emissions are reduced to the rate at which they can be removed and permanently stored by the natural sinks, i.e. primarily the world's oceans and secondarily by ecosystems. If this is not possible in absolute terms, i.e. if we can't reduce the rate at which human-caused emissions are emitted so that they match the rate at which they can be removed and retained by the world's ocean and ecosystems, then any any residual emissions will need to be removed artificially in order to leave net zero in the atmosphere at the global scale. So it follows that net zero emissions is a collective endeavour on part that's got to be undertaken on the part of all the people of the world, all the governments, all non-state parties. It follows that net zero emission cannot be achieved by any one national, sub-national jurisdictions or any one organisation. Organisations can contribute to the global goal of net zero emissions through implementing a decarbonisation transition plan for their, what I would call, feasible share of this mitigation burden. So net zero emissions is a global goal. And understandably, given the importance of this concept scientifically, net zero emissions has acquired various social and political meaning. It's a political commitment that action is being taken in support of implementing the Paris Agreement on the behalf of governments. It can be used as a branding exercise for enhancing green and social environmental responsibility reputation and SIR branding, that should be. And I'm not saying that negatively. That's a good thing. If people are doing good work, they should get some reward for that. And it can be also a public statement that signals fundamental shift in an organisation's mission and vision and strategic priorities. Now, because of the welcomed uptake by non-state party actors in net zero emissions, the UN commissioned a high-level expert group to write a report on the net zero emission commitments of non-state entities, organisations such as companies and corporations and universities, and subnational entities like state governments and local governments. So this report was released in 2022, and it has 10 recommendations. I can thoroughly recommend the report. I think it's very good. I'm going to talk about the first 3, which relate to announcing a net zero pledge, setting net zero targets, and the use of voluntary credits. And I want to spend most of my remaining time talking about using voluntary credits, because that's the one that I think is the most problematic, that we need to have a very good understanding of. But all of those 10 provide some very useful guidance. One of the recommendations from that expert group was that net zero emission transition planning should encompass what I call scope 1, 2 and 3 emissions. I'm sure all of you have heard these terms before. Very simply, scope 1 emissions are direct emissions from owned or controlled sources. Scope 2 emissions are indirect emissions from the generation of purchased energy. And scope 3 emissions are all indirect emissions not included in scope 2 that occur in the value chain of the reporting company, including both upstream and downstream emissions. And for many organisations, such as universities, one of their main scope 3 emissions are aviation emissions. Another key net zero emission planning strategy is to follow the mitigation hierarchy. Again, I think many, if not most of you, will be familiar with the concept of a mitigation hierarchy. In this context, you take action, you prioritise mitigation investments and efforts to avoid emissions. You can do this by purchasing clean energy, by generating clean energy on site, by replacing your diesel fleet of cars or petrol fleet of cars with an EV fleet. That's avoiding emissions. A second prioritisation then is to prioritise mitigation investments that reduce emissions. You can retrofit existing assets. You can have more energy efficient design. You can have virtual meetings. Finally, the third step in the mitigation hierarchy is that there should only be a relatively small quantity of residual emissions that somehow need to be compensated for. And most people, when they look at compensating residual emissions, of course, think of offsets. Now, Australia has, the Australian government has actually established a offset scheme. It's called Australian Carbon Credit Units, Australian Carbon Credit Units. It's an activity that removes, and this is copy and pasted from the government's website. It removes an equivalent amount of carbon from the atmosphere to that emitted by someone. Avoids an equivalent of carbon being emitted by someone somewhere at some point of time in the future. Actually, that's my paraphrasing. But it's either a removal carbon credit or it's an avoidance one. And this is from the website. So the Emission Reduction Fund provides businesses with the opportunity to earn Australian carbon credit units for every tonne of carbon dioxide equivalent a business stores or avoids emitting through adopting new practices and technologies. You can have new technology, upgrade equipment, change business practices, change the way vegetation is managed. So participants in the scheme can earn Australian carbon credit units for every tonne of carbon dioxide equivalent they store or avoid emissions, and they can be sold and can generate participants' incomes. So the idea is that you, if you're an organisation, you can offset, compensate for residual emissions by buying credits that have been generated under the ACCU. So that assumes, of course, that offsets are a good idea. Well, just to note that in practice, this approach actually really impacts people's motivation to follow the mitigation hierarchy, because your motivation, if you like, to follow the mitigation hierarchy to avoid and reduce is very much determined by the price of purchasing carbon credits to offset your residual emissions. If the price is too low, there's very little. People will go to what the cheapest option is. So if the price of credits is too low, they'll go straight. They'll, if you like, bypass level 1 and 2 and go straight to compensation. But there's quite a few problems with offsets. I've listed 4 there. Removal offsets are not like for like. Already we've got more offsets being sought than exist. Not all types of carbon credits actually remove emissions. We don't have an integrity system in place, and in one sense, buying a fossil fuel offset undoes the good work in generating the carbon credit. I don't have time to talk about all of this. I'm just going to talk about 3. And the first one is really this issue of like for like, and it's really the most important one. We assume if we buy any kind of carbon credit, it's equivalent to a pulse of CO2, fossil fuel CO2 that's put into the atmosphere. So whether we've removed it by planting a tree, for example, which is the most common form, we assume that that's equivalent to the carbon not have the carbon being in its original fossil fuel reserve. And this is actually not how the global carbon cycle works, and why I wanted to spend some time talking about the global carbon cycle, because unfortunately a fossil fuel emission has what's called a long atmospheric tail, or if you like, has a very long atmospheric lifetime. Fossil fuel and ecosystems, and if we're planting a tree, we're kind of trying to take an ecosystem approach. They're actually not equivalent in terms of the longevity of the stock, the stability of the stock. And if you think about it, if we can plant a tree, if we're planting a tree, it's where a tree could grow naturally. And if the tree's not there now, it's because it's been previously cleared. And of course, all our ecosystems were operating in that global carbon cycle before we started mining fossil fuels. So fossil fuel emissions are really additional to emissions from land use change and forestry. But if the sink you're putting a fossil fuel emission into doesn't have the same longevity and stability as the original reservoir, fossil fuel reservoir, it's just a delayed emission. Okay, equivalence has to mean forever, Otherwise, the offset is just a delayed emission, because the original fossil fuel carbon wasn't going anywhere naturally. And this is a graph, shows the output from a simulation model of the global carbon cycle. It shows you the atmospheric lifetime of a pulse of fossil fuel CO2. The vertical graph is the fraction that remains in the atmosphere, and the bottom graph is the time, which you can see is it's in years, but the right-hand side, it kind of goes to thousands of years, 10 to 100,000 years. And to cut a long story short, the lifetime of the airborne fraction of a pulse of CO2 is about 300 years for the first 75%, but about 30,000 years for the remaining 25%. It takes about 30,000 years for the ocean, okay, for a pulse of CO2 in the atmosphere to end up in the bottom of the ocean, which is the natural sink, which is permanent and equivalent because it's effectively forever. It takes thousands of years. So this is the fundamental problem we've got with offsets. The offset mechanisms or projects we're talking about don't have true equivalence. The other problem we've got is that everyone thinks offsets are such a great idea that just about every national government that can has included in their nationally determined contributions, i.e. their net zero emission pledges, to account for a lot of that net zero emissions through basically tree planting. So if you look at that top left, this is from a report I was a contributing author to, came out, it's now done annually, came out last year, the Land Gap Report, it was called. The total area of land needed to meet projected biological carbon removal in national climate pledges is almost 1.2 billion hectares, equivalent to current global cropland. And in the middle it says half of those pledges, 633 million hectares, involves reforestation. So if the government, the governments of the world, and this is not even non-state actors, just the government of the world, have already said they want to use up half the world's cropland to offset fossil fuel emissions by planting trees. I mean, it's completely unrealistic. It's a totally unrealistic amount of land-based carbon removals from governments, let alone what non-state actors might want to do in terms of offsets. And this gets also back to the issue that there's more than one type of offsets, and two of them don't actually remove any carbon. So there is an offset removal. That's when you plant a tree. Okay, the assumption is you sequester an equivalent quantity of fossil fuel emissions. The assumption is actually you're neutralising the additional radiative forcing from the fossil fuels, but the problem is not like for like, as it's really only a short-term removal into what is not a comparatively long-term and stable carbon reservoir. Many of the offsets that people buy are actually avoidance offsets. They're paying someone to prevent the emission of an equivalent pound of fossil fuel emission in the future. The assumption is it reduces total greenhouse gas emissions, but it doesn't remove from the atmosphere any previously emitted carbon. It's not a removal offset. Then the third removal, which is neither a removal offset or an avoidance offset, it's really a SIR offset, a social and environmental responsibility offset. You invoke the polluter pays principle to place a cost on emissions and promote behavioural change. You're advancing progress towards net zero emissions, you're providing funds. Well, you're assuming you're advancing progress towards NZE. You're assuming you're providing funds to promote the SDGs, perhaps in developing country. You're hopefully enhancing your ESG reputation. But the problem is, these things may have nothing to do with actually removing carbon, and we're actually making no progress towards. We're just fooling ourselves that we're actually making progress towards global net zero emissions. So what do we do about Scope 3 emissions? And as I mentioned, for many organisations, Scope 3 emissions are the most tricky to deal with because for a couple of reasons. One, you're buying a service from someone else that's generating those emissions, so they come about from the service you're buying. And for organisations like universities, the main chunk of our Scope 3 emissions are actually aviation emissions, and most of them are actually long-haul aviation emissions. Well, of course, the way when you have as a core part of your business plan, and this is true not just for universities, there are many enterprises, both social enterprises like universities and for-profit enterprises like corporations, where aviation travel and long-haul aviation travel is kind of hardwired into their core business model. So the UN high-level expert group, I think, had some very sage advice about what to do with Scope 3 emissions. And I've got some quotes. Non-state actors must prioritise urgent and deep reductions of emissions across their value chain, i.e. follow the mitigation hierarchy. High integrity carbon credits in voluntary markets should be used for beyond value chain mitigation, but cannot be counted towards a non-state actor's interim emissions reduction required by its net zero pathway. Non-state actors cannot buy cheap credits that often lack integrity instead of immediately cutting their own emissions across their value chain. As guidelines emerge for a high integrity voluntary credit market, credits can be used above and beyond efforts to achieve 1.5 degree aligned interim targets to increase financial flows into uninvested areas, including to help decarbonise developed countries. What they're really saying is that non-state actors should buy, if they're going to buy credits, right, they should be using them for their to help others decarbonise. Right? The important work of incentivising, recognising and rewarding high integrity companies who purchase and retire carbon credits to go further and faster in their climate action. So you put those last two together, is what they're saying is what non-state actors should be doing is if you're going to buy credits to compensate for your residual emissions, don't actually count them towards your net zero emission spreadsheet calculation, right? Use them to drive behavioural change and put a cost on emissions to drive behavioural change, and direct that money to where it's needed most, where it can do the most good in terms of avoiding emissions in the future. And if it's from a voluntary market or even a regulated market, a compliance market, you can retire them from that market so that they can't be resold. Right? So there's some very strong, but I think very high integrity advice there. Now, this is where we have a little block in the, oh, there we go. Let me say a little bit more about long-haul aviation emissions because, as I said, for many organisations, including my own here at Griffith University, this is the largest chunk of our Scope 3 emissions are actually long-haul aviation emissions, but this really applies to all aviation emissions, not just long-haul. Griffith University actually has a decarbonisation plan. It's budgeted, it's in place. It's doing an excellent job of dealing with its Scope 1 and Scope 2 emissions along the lines I talked about before. And as part of the ongoing discussions at our institution about our Scope 3 emissions, Professor Tim Riley and colleagues spent a significant period of time the last couple of years doing research into options for Griffith to do this. And this was actually published in that journal article I've cited here. So here are some of the mitigation actions that an organisation like a university, and like Griffith University, could take to help manage its Scope 3 emissions. We could have policies that enable staff to take a smaller number each year of higher value international trips by staying longer and doing more once there. We could have policies that give equal prestige value for academic in terms of academic performance reviews and promotion, give equal prestige value to virtual and in-person attendance in international events, i.e. virtual is as worthy, academically worthy as in person. We can invest in technology that enables more effective virtual interactions, meetings, research and teaching. 10 years ago, I went to a meeting at the Rio Tinto offices in Brisbane in their boardroom, and they had an incredibly effective virtual interactive boardroom platform, and that was a decade ago. So I know, there's a lot you can do with technology these days, have much more effective virtual meetings. One way of changing people's behaviour is providing them with information. We can be providing staff with regularly updated information on their aviation emissions. This can be aggregated to different organisation levels, from individual through school, faculty, group. Finally, we could even think about introducing an internal cap and trade scheme with a price on emissions, aviation emissions, and a cap that decreases over time. If you have a cap, it's got to decrease over time. That's just an example of the kind of actions that could be taken that would contribute to a reduction in long haul and even short, medium haul aviation emissions within an organisation such as university. So to conclude, I'd just like to conclude with some simple recommendations that I would encourage people to think about in their decarbonisation planning and in their climate transition plan. I can recommend the UN high-level expert group's 10 recommendations. The report's very accessible and there's some detail you can drill down into. I do recommend setting an organisation's net zero emission target and timetable as explicitly contributing to the global net zero emission goal, not to set it as an internal spreadsheet net accounting goal. And so what do I mean by that? Well, an organisation can set up an Excel spreadsheet or some other kind of spreadsheet and have all their sources of emissions in scope 1, 2 and 3, have all their mitigation actions are going to take to avoid and reduce those emissions, and then keep track of their carbon footprint, and periodically look at what their residual emissions are, just buy offsets and subtract them from their residual emissions and say we've achieved net zero emissions. Right? That's what I call that internal spreadsheet net accounting goal. Many organisations are doing that now. Many universities, including in Australia, are doing that now, who I won't name. I'm suggesting that lacks integrity. It's not consistent with the scientific understanding of net zero emissions. So we set our goal in the global context. We do want this internal spreadsheet net accounting, but we're realistic about what's happening with we're transparent and realistic about what's happening with our scope 3 emissions. As I say, we really have to take the mitigation hierarchy seriously and avoid and reduce as much as we can scope 1, 2 or 3 emissions. As I say, many people, especially if the price of offsets is low, they will skip levels 1 and 2 in the hierarchy and go straight to level 3 and jump straight to net spreadsheet accounting offsets straight up. So let's be transparency. One of the foundations of integrity is being transparent. Let's be transparent on our residual emissions. I can tell you now, everyone is going to have residual emissions. We can't eliminate them. There are in the short term, they're just technological impediments and barriers for us as organisations to do this in the short term. It's much better that we're transparent about what our residual emissions are, including scope 3 emissions and long-haul aviation emissions, and be transparent about how we're managing them and tracking how we're reducing them over time. To have integrity, to me, to have integrity is to be transparent and to be showing how they're managed and that they are being reduced. That's far more important than just buying offsets and claiming a kind of spreadsheet version of net zero emissions. Finally, if you do purchase credits, these should be high integrity. There's a lot in the news in the moment about what that constitutes. We can talk more about that if people want during Q&A. They should be additional to your reduction targets. You can use them to provide a pricing mechanism to lever internal behaviour change. You can use them to promote SDGs. And if you do purchase them, retire from them from the market, because that actually makes, I would argue, a very good contribution to NZN. And also at the end of the PowerPoint, which will be made available, this is a list of those two reports I mentioned at the beginning, and a number of the peer-reviewed journal articles by myself and Griffith colleagues and other colleagues that I've drawn upon in this presentation. So thank you, and Susan, I'll hand back to you.
Wonderful. Did my camera pop on?
Yeah, I'm just going
Brendan?
to, in a minute, wait for my screen to
Excellent.
rejig,
Beautiful.
and I'll be able to stop, sharing there.
Wonderful. Okay, so we've got some amazing questions flowing through. And first off the rank was Debbie Firestone. Debbie, you're more than welcome to turn your camera on and ask this question if you wish. It's about the climate action tracker diagram, Brendan, and she's talking about RCP 8.5, which is used for SLR and precipitation modelling to estimate local coastal hazards, drought and flooding implications. She's interested in how that RCP 8.5 lines up against the climate action tracker diagram scenario that you presented.
Oh, well, yeah, well, like RCP 8.5 is one of the emission scenarios. And it's called business as usual scenario, but it's if there's no, basically it's the emission, it's where we'll end up if there's no effective mitigation action taken. So in terms of that climate tracker diagram, it's the
bad one.
It's the worst one, you know.
Yes, the 2 point something. Yeah.
Well, it's the top of the left-hand one, which is basically current policies, but it's the top range of the modelling. So it's about 3.4 degrees by the end of the century.
Crikey. I hope that answers your question, Deb. And I think that is the wisest model to use. Like everything else is a bit optimistic, isn't it, at the present time? Okay, Stuart Elliott has a great question. Stuart, did you want to ask your question, or are you happy for me to?
Yeah, in terms of biochar, yeah, and I think we and Australia is a case in point with our agricultural land. It's suffered a lot of degradation. We know we continue to suffer soil erosion, and that even for our farming land, it's depleted in terms of carbon. Its carbon stocks are below certainly what it would be naturally, but what a healthy farmland should be. So there's certainly more carbon. There's various practices that can help put more carbon back into the soil, but there's a limit to how much you can do that, because if you put too much carbon in soil, the nutrients get bound to the carbon, and the plants can't uptake it, and the soil in effect becomes infertile. But we have a wonderful PhD student, Kate Kingston, in planetary health and food security, who's actually looking at the role of biochar in the wine industry in Australia, in viviculture, and how that can help improve carbon and nutrient and water retention capacity. So biochar has definitely got a role to play in healthy farming land, agriculture.
Thank you. Stuart also had a question about managing community waste. He's pointed out that recycling rates are stagnating, waste types are changing with a lot of chemical contents and packaging issues. Landfills are filling up, but everyone's burning their fossil fuel, burning their rubbish, which creates more fossil fuels. So he's asking, how can we cost effectively decarbonise this wicked problem?
Well, I believe that Professor Chingran China's got a CRC in circular economy. So I would direct those questions to him. I think that's one of the issues they're looking at.
Okay, thank you. Well, we can put that in the chat box, Natasha, if we could do that. Hamish has got a very witty question. He suspects that offsets that are purchased from airlines are essentially the same as indulgences purchased from medieval popes.
Yes,
is that fair?
I think that's a very, I would say that they are to help absolve people of their sins of emission.
Wow.
That's a joke. It's a climate joke.
It's a terrible climate joke.
So they're
So what should we
indulgences.
do?
They're indulgences for our sins of omission, right? I mean, I'm just kind of agreeing with him. Well, you know, it's a big problem. The airlines have all gone into into offsets, and to be fair, to all companies and organisations and universities, for that matter, people have been told by their governments that offsets are a good thing, right? Our national government has an offset program. Under the Paris Agreement, Article 6, they're still negotiating the rules for the international trade of carbon credits and offsets. So everywhere people look, they're being told offsets are a good thing by their governments. So, I don't, this is not trying to, it's a matter of educating people and informing people about what they're actually doing. What are you buying? Just be clear, what kind of offset are you buying? Is it a removal offset? Is it an avoidance offset, or is it a social environmental responsibility offset? Right? And what's the integrity of the offset that you're buying, and what is being done with it? I mean, most of the offsets credits that you buy as an offset none of them are linked in any direct way to national government's greenhouse gas inventory reporting. Right? Like, the idea is they should mysteriously appear if they're doing their job, but there's no direct link. If you buy a carbon credit, it doesn't mean there's 1 unit of carbon less in the national inventory or anything like that. So I think we've got a massive education issue here, but we have colleagues, Professor Tim Riley and Professor Susanna Becken are deeply engaged in discussions with the aviation sector about these very issues. Susanna's online. She may well want to take a question on that.
And there's a question from Tim coming up. But first, Emily Carr from DECA, she's interested in how to communicate more ambitious commitments by organisations who are seeking to minimise use of offsets, but are nonetheless hamstrung by an inability to reach real zero due to extremely hard to abate direct emissions from, say, nitrous oxide. Is there another goal we can define for the world so we don't stop at net zero without ignoring the practical realities of real zero?
Yes, I think I think that is a good suggestion, to have a term other than net zero emissions. I do think net zero emissions should be reserved for the global goal of net zero emissions in the context of the global carbon cycle. So we do need another term, because I have tried to stress that we do need to be realistic. And I think we do need to be having levers to change our organisation behaviour, right? And putting an internal price on carbon is one of them, and one way of doing that is by having people buy offsets of some kind. If people say to me, but I really want to buy a credit, I would say, well, buy one from a compliance market and retire it from the market. So that's actually a highly credible thing to do.
Okay. Yi Bian has a very cogent question. So he's looking at basically technological development, and it's keeping up with the pace of fossil fuel consumption. So if we're thinking about the timeframes, how should we complete the decarbonisation task in a timely manner? It's a billion-dollar question, isn't it? How can we increase the urgency?
So is this asking, is there a technological solution for removing and storing carbon?
He's saying it's not going to be fast enough. Yeah.
No, it won't be. I mean, and if you look at the scale of emissions that have to be removed and permanently stored, it's the current carbon, I forget the exact statistic, but the current amount of emissions which are being technologically captured and stored it's well less than 1%. I mean, there's just no conceivable pathway that would scale this up globally, in any kind of realistic timeline.
Tim Riley has a question. How hopeful are you that businesses and governments will change tack to hope to properly address the NZE issues moving forward?
Well, I was born an optimist. I am operationally an optimist. So, look, everyone is slowly coming to terms with their reality, right? I mean, I go back to my first slide with the cover page of the World Meteorological Organization's, global climate, State of the World's Climate 2023 report. I mean, just read that a couple of times and let it sink in, So, I guess we can only hope that like we all know what the problem is, right? We have vast amounts of capital invested in current fossil fuel energy production and distribution and use, and we need vast amounts of that capital shifted into the clean energy systems that we need, and we need massive kind of lifestyle and behavioural changes and value change to accompany all that. So, this is a massive, I mean, it's an economic revolution as well as a kind of a technological one and a lifestyle one. So I don't expect it to happen overnight. The UN Framework Convention on Climate Change was signed in 1992, right? And the Conference of the Party meets every year, and we just have to keep going forward. There is no alternative. There is no alternative but to be optimistic and to keep going forward, however tiny and frustratingly small the steps are.
For Lynette is taking up that question about, but a really interesting idea. What can insurers do to change the behaviour of companies and organisations they insure to influence their behaviour on emissions reduction?
On emission reductions, well, that's an interesting question. I am not an insurance expert. I'm happy to defer to any colleagues online who want to take that call. I haven't thought. I mean, I've been mainly we've done work with insurance in relation to impacts and adaptation, which is a huge issue. But yeah, in terms of mitigation, that's interesting. There might be someone else who can answer that. Ian Edwards has his hand up. He might.
Ian Edwards, excellent.
Ian wants to respond to that. I'm happy for him to take the question.
Okay. You can be thinking about. Oh, here he is. Good.
Oh, sorry. Can you hear me?
Yes.
Yep.
Okay. Yeah. There is a initiative that insurers can sign up to under the GFANCE framework, which is the Glasgow Finance. I can't remember the exact name, but it was a framework set up just subsequent to the Paris COP by Mark Carney, who at the time was the head of the Financial Stability Board of the G20. So it's a very finance orientated framework. Under that framework are various initiatives. One is the NZBA, which is the Net Zero Banking Alliance, and there's also a Net Zero Insurance Alliance. And essentially what's required is whoever signs up to that signs up to reducing their real emissions, as in not their net zero emissions as we've just been discussing, but their gross emissions in accordance with a normative pathway that takes them to net zero real zero by 2050. The problem is, at the moment, there were quite a few insurers and reinsurers who signed up to that, but a lot of them are dropping out for various reasons. But that is something from an emissions perspective that an insurer can get involved in.
Thanks, Ian. That's very helpful.
Okay, great. Let's try and get through two more of these questions. Hopefully that's answered Emily's question. He said, what should we call it? I suppose gross emissions, real emissions.
Yeah, I mean, they are gross emissions.
In every sense.
Gross emissions is not a very catchy term. Real emissions might have a bit more cachet.
And we might give Tiago the last question, which is about used batteries and the adverse effects of clean energy. Used renewables tech. What do we do with that?
Well, I guess this gets back to our CRC for circular economy. So I would defer to my circular economy colleagues on that one.
That's right. They have been coming up with some extremely ingenious ways to recycle community batteries, for example. So Emily's saying, what's in the middle of net zero and real zero? What's the middle ground there? I guess anything that's emissions reducing behaviour, right? A trajectory, emissions reducing trajectory, something like that.
It's the vector. It's the director and strength of change that we're needing to emphasise.
Sorry, I'm not sure if you can hear me.
Yes, we
I'm
can.
having trouble with the microphone. I guess my question really comes down to, this is a communications exercise. If you can name it something as catchy as net zero, what is something that we can kind of call on that actually demonstrates what that midpoint ambition is, that still recognizes the challenges, but seeks to kind of differentiate between those that are claiming net zero but offsetting to the maximum? I guess I'm talking more from a communications framing point of view. How do we kind of give light to those that are on the more ambitious end of net zero, because they're minimising offsets and pursuing more direct abatement?
Oh, here we go. Suzanne's swooping in to save the day.
Hi, how are you? I was just jumping in, but Brendan, maybe you want to have a stab at that.
After you, Suzanne.
Okay. I guess what's happening with some offsetting companies is that they actually don't use the word offset anymore, but contribution. And so in our research with Brendan, we've started to promote 2 targets. So you have your gross or real, I quite like the word real reductions. You work on the decarbonization, and if you contribute whatever removal or avoidance project, that's a contribution to the global net zero. And some providers like My Climate in Switzerland, literally, you will not find the word offset on their website. It's a contribution to global climate action. And I quite like that, to have the 2 different, basically separate, so you don't mix them on the accounting sheet. It's maybe not the sexiest term. Maybe you can come up with a better one, but that's at least a principle.
Yeah, I like that. You're reporting on real reductions, and it's a contribution to global NZE, but perhaps we can have a workshop soon to kind of have a brainstorming workshop. I mean, take those concepts that Susanna just said and have a bit of a brainstorming about messaging, because you're absolutely right. If we can get the messaging right, this can sell. A lot of people are, the word is spreading about the issues we're talking about today.
Yeah, because
it's the opposite of greenwashing, isn't it? It's the opposite of green. Like, how can you tell what's an authentic, people making an authentic contribution? In human rights law, we talk about progressive realization. So, there's a few terms around the traps to kind of talk about an evidence base too for an actual contribution. So I think that's where a lot of people come unstuck in the litigation that I've seen. They can't actually prove. They make lots of claims about their emissions reduction without any evidence base. So I guess there's got to be something about evidence base and rigorous authentication of emissions reduction. But I'm afraid we've come to the end of our time.
Sorry, just very quickly before you wind up, I just wanted to let everyone know that Susanna and I have written a discussion paper based upon the presentation today that explains some of the things I've said in more detail and gives lots of links to source material. So that'll be available on the website shortly as well.
Thank you so much, everybody. So we had 70 people at our height, and a lot to think about. One of the wonderful things about working with Brendan, even though he's optimistic, his slides leave you in a state of complete despair generally. But I always learn something very, very important, and this is such an important issue. So thank you all so much for joining us. And thank you to Brendan. Please show your appreciation with the emoji of your choice. And check our website for this presentation and the slides and the paper, and we will be in touch about our next webinar soon. Thank you very much, everyone.